Merci.
Alors pour cette
Well, for this panel discussion, I'll welcome three specialists of the maritime world. Lise DETRIMONT, you're the General Delegate of the Windship Organization. We'll talk about wind. You've been working on decarbonization of maritime transport with using wind as an alternative. Your neighbor is Xavier LOZAC'H. You're head of maritime hull underwriting and naval construction at AGCS. Olivier SANQUER, you're the head of maritime activities at Marine VINCI Énergies. And also we have a specialist of the air sector, Xavier LOZAC'H, chair of the Energy and Environment Committee of the Air and Space Academy. Will always stand on two legs, maritime and air, to understand what we should do in terms of decarbonization of transport. Laurent Leblanc's explanation was very clear about decarbonization, what the challenge is for us, ahead of us, and so concretely, how did people realize that there was this need? How did it come about? Is that as recent as it seems? Maybe, Lise? Well, we've just heard it. There's an issue with traffic. In 2019, there were still 11 billion tons of goods that were transported on the sea by nearly 60,000 vessels. So traffic is still increasing. There's been a massification of volumes that was enabled thanks to bigger and bigger sizes of vessels. We saw that very clearly this morning. And at the same time, although this is a mode of transport that probably emits the least greenhouse gases, there is this increase in volumes that will lead 3% of global CO2 emissions because of maritime shipping to rise to 17% by 2050. It so happens that marine shipping, similar to air transport, was not included in the Paris Accord for 2015. The IMO is in charge of reductions. States are not directly responsible, and at the IMO there is a principle which is one of equal treatment, which is quite different from common but differentiated responsibility that applies as part of the UNFCCC. So there was a bit of lag before the IMO issued a greenhouse gas reduction strategy that was issued in April 2018 with short-term measures, with more and more binding energy efficiency measures and more binding goals that will be issued by 2023. And in 2021, in November, there was COP26 that focused on the need to accelerate this awareness. 100 countries signed an agreement to reduce methane emissions by 30% by 2030, and the European Union is pushing hard with indices on greenhouse gas emissions index for ships, and maritime shipping being part of the EU ETS. So regulatory developments lead to more and more awareness, and I think that ship owners are really part and parcel of this system. To illustrate that, Olivier SANQUER at VINCI, how did you go about it? Let's talk about VINCI Énergies mostly. Yes, of course, sorry. VINCI Énergies, it's a CSR matter mostly, this new awareness. Our activities are mostly related to the integration of systems for customers in industry, in services, or of course in the marine sector, because that's what we're focusing on now. And if you look at our business at VINCI Énergies, once we've decarbonized our transport, so our vans and light vehicles, we'll have mostly decarbonized our fleet. Here we're talking about scopes 1 and 2. But if you look at scope 3, if you look at our customers and clients, how we can help them accelerate their own decarbonization, you can see that the challenge is much bigger. You can consider that with scope 3, you can decarbonize up to 30 times more than our own direct business. And since we're working in the marine business, of course, the maritime business will become part of this rationale. Why? Because we've been working for many years on the vessel power plants, how to produce power on board and distribute it. And so we took a look at a technology that was becoming available to decarbonize transport. What could you say about air transport? Well, air transport, I listened to the presentations earlier. We're not quite twins, but we're more than first cousins with maritime shipping in terms of figures, because we're roughly at the same level of carbon emissions, CO2 emissions, roughly 2.5 to 3% in that ballpark. And you can see that the growth of emissions tracks that of GDP, and it seems almost inevitable. So 700 million tons in CO2 emissions versus 900, I think, for maritime, but it's quite similar. And for cargo transport, 40% in value of international cargo that is transported. And tonnage is completely different, of course. And the number of passengers is quite considerable, because in 9 trillion passengers per kilometer, so 20% of mankind sometimes takes the plane, and 80% don't ever fly. But anyway, another commonality with maritime is the fundamentally international aspect. Regional markets are important, but international markets are the biggest consumers, and there's hardly any alternative for mass transport, because we're doing mass transport of people and goods. How did we come to this new awareness? Well, for some time we've been talking about it in the aeronautics business. 25 years ago, I created a forward-looking group looking at hydrogen. Russians were doing in-flight testing of hydrogen-powered aircraft, and then it all petered out. And so with the lack of forthcoming technical solutions, it seems that the aviation business was sort of trying to postpone this seemingly long-term goal. And then with the rise of fairly efficient biofuels and e-fuels, of which I'll talk later, and startups developing all that, we started believing in it 2 or 3 years before government started to taking a look at that. So we started believing. And now EU regulations are now following. Elsewhere, there's not much. In developing countries, they're not doing anything, you could say. And soon, ICAO, the International Civil Aviation Organization, is going to take a very serious look at that. So we have to start looking at it. Xavier LOZAC'H, that's a provocative question. Insurers, why are they at all concerned with that? Well, it's true that awareness of that issue for insurers is fairly new. Maritime insurers are mostly worried about the safety of vessels and the environmental aspect developed at the same time as all these technologies. So now every insurance company has this idea of ESG in its DNA, the idea of improving their responsibility in this regard. So now we are following and supporting all the stakeholders in this industry. So it's not always easy. When you're an insurer, this is new technology. It's more or less unknown. Although insurers may be fond of chance, they don't really like the unknown, so they may have different risk appetites, but they are ready to support these projects that are going to be part and parcel of our future. Talking about a group like Allianz is very strongly involved in an approach to decarbonize its own business with 2 deadlines, 2030 and 2050. So we are part of the same momentum as our clients, because IMO standards will apply from 2030 onwards. We saw that with the presentation by Mr. Leblanc in particular. So the idea is for the whole community in the next few years to support our clients as best we can, with or without restrictions on many solutions that will need to be invented. Because now, well, we know traditional situations. Now it's a new environment that needs to be explored and discovered. Tomorrow morning with Cécile Soubran, we'll have an in-depth analysis of what AXA is doing on that, especially in addition. So we've already seen quite a few solutions, but what are the solutions for decarbonization that you're considering for maritime transport? Lise and Olivier, I think you've thought about that together. You have a quick presentation on top of what Laurent said. Yes, many things were said earlier. This is work that was done by the Maritime Eco-Energy Transition Coalition that led to the creation of the 2050 Committee for Zero Emissions Vessels and Harbors. I'll add two things to what was said earlier. We have challenges both on land and at sea for the decarbonization of shipping. At sea, we'll work on ships themselves, their propulsion systems, on onboard energy management, technologies in the design of winds, hull cleaning, very pragmatic measures, and also the operation of the ship itself with speed and velocity management that helps drastically reduce emissions. We saw that in 2008 when container ships reduced their speed from 25 to 18 knots, but there are also challenges about what's going to happen on land in terms of production, storage, processing, and bunkering of these alternative fuels. And of course, the financial cost of this transition, we are talking a lot about what's going to happen on land, because that's 800 billion to 1.2 trillion to be invested by 2050 to have a successful transition, mostly on land, because 85% of the spending will be on the fuels. Here we're talking about decarbonization aligned with the IMO goals, the 50% reduction. If we want to go to zero emission, that's even more. Over $60 billion invested every year by 2050. So there's a whole lot at stake. So to illustrate what was said even more, people are banking on zero-emission fuels that will be produced based on hydrogen thanks to decarbonized electricity. Now the 300 to 330 million tons of oil that are used by maritime industry are roughly 3,000 terawatt hours produced with a combustion engine yield of 50%. Now you'll have more complex production chains with decarbonized electricity with lower yield. So you'll have 2 to 4 times more needs for decarbonized electricity. So that's 6,000 to 12,000 terawatt hours. So that's 2 million wind turbines or 2,000 1 gigawatts nuclear reactors. That shows the challenge for the maritime industry. And you can't just bank on one solution. We'll need to bank on an energy mix and hybridization. And I'll throw it over to Olivier. Well, yes, indeed. Let's look at the fact that it won't come from a single solution. It seems obvious that one single solution will not help us decarbonize. We like this Kaya equation that shows that there are 3 main families of actions to undertake. A first one will be to reduce the CO2 content in fuel and in the energy that is consumed. The second lever will be to work on energy efficiency on ships. And the third lever will be to work on sobriety. And you can see that working on the CO2 content of energy leads you to several solutions. Each in isolation is not enough. They all have their shortcomings, and so we'll need to find ways and means to combine them, to find the right uses, or even to have multiple uses on a single boat. Let's take biofuels. Biofuels will not be sufficient because we know that there will be conflicting uses with farming for food. So we'll never be able to decarbonize only with biofuels. E-fuels, the production costs are what they are. Electrification and batteries, You can see that we know that batteries will not enable us to bring huge amounts of energy on board, especially for transatlantic voyages. They won't be enough in and of themselves. Why not capture CO2? I don't think we've talked a lot about it, but we could capture CO2 on board. Here that requires major infrastructure, and we'll come back to that later. Sail propulsion might also be a solution. And then working on energy efficiency. One major family of work will be to work on hull shapes, reducing drag from the ships. You can see new technology emerging like foils, but that won't be enough in and of itself either for total decarbonization, because you can expect reductions of 10 to 20% in consumption. Talking about operating excellence, that's how to optimize energy use on board and putting systems in place to reduce energy consumption on ships. And lastly, sobriety. Why not reduce speed? But if we continue consuming and transporting so many goods and equipment, if we reduce the speed of boats, we'll need more boats. So it's a catch-22 situation, it seems. And I'll skip overall sobriety because that goes way beyond the scope of our involvement. And here, society as a whole will need to change. Another avenue that's worth looking at, or there are two avenues that are worth looking at. What are we propelling and over what distances? What are we propelling? That's the size of the ship, simply. And you can see that there will be variable power from 50 kilowatts to 100 kilowatts to 100 megawatts for super container carriers or big cruise ships that have similar power now. And you can see that the technology to put in place in the boats will depend on the power that's needed. And another parameter is the shipping routes and the duration. If you're on a short haul route, or if you're going around the world, the amount of energy on board will guide the choices to be made. So we were talking about hydrogen and batteries earlier for short journeys. That could be suited, but that won't be suitable at all for transatlantic transport unless there are technological revolutions that I haven't imagined yet. And so maybe other technologies can be used for fuels on this type of journey. Lise, you're betting on wind. Could you explain us what we can do and what could be done in the midterm? Wind energy. It's true that it's been left behind for about 100 years, and we're never going to come back to the big clippers of the 1930s, although they were wonderful. The idea is to use this relatively abundant energy available immediately and free at the point of use and for the whole lifetime of the ship. We've been using wind for over 5,000 years. Now we are returning to it with different technologies, and you might distinguish between the type of materials where they're located on deck, the tilt, the size. In the Windship organization, which is an organization that unifies players in this area, and that are part of an international network, we've tried to classify all that to illustrate it with pictures. So systems that are either active, that use some energy. Here, this is the suction profile invented by Commander Cousteau in the 80s. So there's a suction and air suction system throughout the profile to increase lift. And so you have wings that have a smaller size than a traditional sail, so that they take up less space. And then there are rotors, metallic cylinders that put in rotation, and with this rotation they generate lift. That was invented in 1924, if my memory serves, and there are some ships that are still equipped with that. Then you have thin profiles, more traditional systems like sails that we know of, but they can be revisited. with different textiles or materials. Here you've got fiberglass and composites, and so there will be less material fatigue on them. And there's a whole panel of so-called thick profiles, new profiles that are fairly innovative in the maritime world, that are inspired by what is done in aeronautics and aviation, maybe inflatable profiles. What Michelin announced last week? Yes, absolutely. This is there's a ventilator under the wind, under the sail, inflating it, and there is a telescopic mast that will rise, and this is a very stable structure, no issues with pressure, and so you can have a lot of lift from that. And all these sail systems are automated. So once again, you won't need to have 70 crew members to operate them. You can have a traditional complement with more skills. Then you have more rigid profiles that can be reversed, and then thick profiles with side plates. And you can see that there are different types of ships that I'm showing because it can apply to all different types. This is a thick profile that was invented for the high sea race, the Oracle boat that won the America's Cup in 2010, with articulated sails that were re-engineered to be placed on an industrial ship. And this boat will is a ro-ro ship that will sail in October this year, and then kites with that will look for dynamic forces with very good stability. So this is really something different. We're using wind energy, putting it to good use, and so the potential is 5 to 20% of propulsion brought by the wind if you're dealing with existing ships that were not designed for wind propulsion, that are being retrofitted, and you can rise above 30% if you're using new builds, even reaching 50 or 70% if you're using mostly wind-propelled ships with specific routes and moderate-sized ships. But the decarbonization potential is very, very high. Now there are 20 high-load ships, 120 to 340 meters for a big mineral bulk ship that navigating on all oceans. There could be 3,700 to 10,000 ships by 2050, and 45% of the fleet will be equipped by 2050. We didn't do these forecasts. Third parties did these studies, looking at the availability and free use of wind. At VINCI Énergies, are you already using these boats and new propulsion means, or is it still nascent? Well, some of them are already insured. I saw two pictures from ships that we are insuring, then on new systems with rigid sails. This is just the beginning of this endeavor. So saying that a maritime insurer doesn't know how to underwrite sails and masts, that would be weird, because maritime insurance has existed for hundreds of years. So for traditional masts, we can do that. Some French insured parties, we won't name names here, well, the brokers will know who they are. But for rigid sails, it's a sort of the unknown. We don't know how to go about it and how to help our customers, support them in this development, how to adapt our terms and conditions and customer retention. It's true that sometimes when you see the picture of the Oracle trimarans, it's a bit scary. Yes, it's a bit scary because that's reminiscent of the Vendée Globe. Well, yes, traditionally race ships with carbon mass, we're not too fond of that. Underwriters don't like them. My peers can correct me if I'm wrong, and they'll hate me in a couple of minutes, but it's true that we're not too fond of this type of risk because we think that carbon has existed for a very long time, but for insurers it's difficult to get a good grasp of the implications. Olivier's response, are you already using it or not? Are we using it? Well, some of you know boats that sail thanks to batteries. In La Rochelle, you can cross the port using boats like that. There were experiments with pure H2 boats on fast ships. These are small capacity boats, and now we are seeing the rise of a number of boat projects that have bigger capacity that will start experimenting with, not just experiment with, but will start applying technologies that I discussed earlier. To name but a few examples, there's the Occitanie region in southern France that will have a fuel cell powered by hydrogen on a dredger with also batteries and traditional electricity production from oil. So this will be hybrid technology. On the Seine, not far from here, Zulu 6 is a Sogestran boat that will also have a fuel cell. And this week we announced that Vedette de Paris would convert to 100% electricity, starting with the first boat first. And you can see that some ship owners and some builders, some integrators are really sticking their neck out with innovative technologies, and we hope that insurers won't be too timid in helping us along. In the Mr. BOUIS, in the aviation sector, what are you considering? Well, I listened to what my colleagues were saying with great interest. There are a lot of similarities for us with the same questions, on fuels and efficiency that should come first, efficiency of operation and good economy of the engines. And here, aeronautics, since the beginning, they've kept reducing fuel consumption per kilometer passenger transported. It's halved every so many years, but this is an inevitable declining trend. And by 2050, compared to today, with fleet renewal and incremental progress down the line, will further halve this consumption that will help offset the higher price of fuel. Now, what energies can we use? Well, in a plane, to go far, you need to store energy that is both light, kilowatt hours per kilo, and also compact, kilowatt hours per liter. So for that, kerosene is really the gold standard. It's about 12 kilowatt hours per kilogram, and roughly the same for per liter. It's a density of 0.8. Hydrogen, even liquid hydrogen that you hear about, it's pretty nice because it's roughly 30 kilowatt hours per kilogram. So that's great, but it's a it takes a lot of space. So now the main avenue we're looking at is that of kerosene in its various possible replacements, so biokerosene or electrofuels, so synthetic kerosene that is produced with various processes that include hydrogen or having co-electrolysis of water vapor and CO2. But for this cycle to be virtuous, you need to capture CO2 from the atmosphere and return it into the atmosphere on a neutral basis. So for that to work, you need to capture CO2 from the atmosphere, which is fairly cumbersome. But you can optimize that with very, very clever processes. And at the end of the chain, you can have, in terms of kilowatt hours, provided by the fuel compared to the kilowatt hours from green energy that are used to produce it. In terms of green energy for e-kerosene, you have the same results as for liquid hydrogen. And that will matter later, remember that. These new fuels are generally called SAFs, Sustainable Aviation Fuels. And so we've begun using it in small amounts. We are able to produce millions of liters. Now we need to go to millions of tons, and of course, we need to reduce production costs quite drastically. And what about batteries and hydrogen? Batteries, well, we can do things on aircraft with batteries on small training aircraft. There's one that exists. It's the Slovenian-Italian company that was acquired by Decarbonization from the US. It's the Pipistrella. It's a small training aircraft that is officially certified and that can fly for about an hour for flight training school for around 550 kilometers. It exists, but that can be scaled up to bigger aircraft if you want to fly Paris to Toulouse with an electric plane. On a 40-ton plane, you'll need 50 tons of batteries, so that's completely impossible. So batteries, forget about that.
Hydrogen. Gaseous hydrogen is a very attractive solution, but it takes up a lot of space, even if you compress 300 bars, for example, like in a taxi or certain buses, it works very well. You need enough space. The weight isn't too great, but in aviation, the flights would have to be very short, so that doesn't really work either. And we don't know how to make fuel cells which are very powerful. And electricity on board a plane, when you're at high altitude and you want a lot of power, that requires a lot of voltage. 1,400, 2,000 meters, it just doesn't work very well. So that comprises major limits. So liquid hydrogen now, that is the holy grail around the world. We talk about this constantly. Liquid hydrogen, minus 350 degrees storage, temperature, it's very attractive. It provides 3 more times energy than normal fuels, but it takes up a lot of space. And it's 70 kilos per cubic meter compared with 800 kilos for kerosene. Plus you have to have a lot of insulation so that it doesn't boil and so that it can be stored on the plane. It's extremely complicated, and that's not all. On paper, you could fly over short or medium length distances, 600 kilometers, 1,000 kilometers, maybe a bit more. Up to that point is not too bad, but for long-haul flights, it's not going to work in the least. Having said this, using liquid hydrogen has been viewed for many years as a possibility, but it's very difficult. In space travel, it's used, but you have to have refueling. And then you have an issue of Seveso. In terms of air transport, if you want to refuel, you'd have to park the plane and then take it several kilometers away for refueling. If you do that and talk to the Paris airports about the possibility, their hair would shoot up straight off their heads. I wouldn't like to say it's impossible, because it could be achieved, but it will be a rocky path. And the economic equation for making the hydrogen, that works. Refueling at the airport, okay, but what about the remainder? Once you've refueled the aircraft and then you have to fly it and control the fuel on board, that will be very complicated, and given the economic costs, I think it is very problematic today. It's quite complicated because you have a lot of information, disinformation, but the economic equation doesn't really work out. Thank you, Xavier. That was very clear. There are a lot of obstacles. So I'd like to put the same question. In terms of shipping, things are moving forward, but they're moving rather slowly. What are the obstacles? What needs to change so that we can move faster? When it comes to wind energy, I showed you a picture of offshore sailing, but no, we're talking about an industrial product. There are no technological obstacles, but you need to develop new industrial products, because let's not forget that these are masts which are going to be extremely tall, extremely wide, made of metal or composite material. Some will be in carbon. It'll depend on the technology. So this is where things are being developed, and it's necessary to produce new industrial tools. Plants are being built in France, We have about 10 equipment suppliers in France who are working hard on this and have been for years. That's 1/3 of all the world's equipment suppliers. So we have a large number of such people in France. It's exceptional. You have the time for industrial development. Prototypes have been made, so we're reaching a reasonable level of maturity. We're beginning to move forward when it comes to the actual facilities. However, the return on investment of these sails or wings is complicated. It's the financing of the system that's difficult. Currently, there's a maritime market that hasn't really put much stock by this kind of thing, and the ton of CO2 that you can avoid. In the economic models, people don't include the fact that the wind is free of charge. So we're testing prototypes currently. We need to convince ship owners to move forward and take the risks. Yet it will take time for the maritime market to evolve sufficiently. Over the next 2 or 3 years, I think, things may change radically. Olivier, SANQUER, what's your position? The technology needs to evolve. R&D programs are fundamental in our work. We need to look today at technology in order to have things which work in the future. The French Maritime Cluster is busy in this area, research institutes too. The idea is to participate together with industry and ship owners and get technologies to advance. We also need to move forward in pace with the certification organizations. Earlier on, we saw how difficult it may be for people like us. We are integrating technologies, yet the surrounding environment hasn't been fully defined. That's a major problem for us when it comes to being sure about how we're moving forward. We work hand in hand with certification bodies, but we're not quite ready yet. Do we need regulations? We talked about certification. Is there a regulatory aspect as well, which might get things to move forward faster? I didn't really understand your question, sorry. Over and above certification, what about regulations? If they evolve, could that speed things up? I think we're just discovering the constraints involved in these technologies. So yes, regulations will necessarily evolve and adapt according to what we discover and the difficulties we encounter. How can we make the boats, the vessels, safe? Yes, indeed, regulations will have to adapt. Is there a cultural aspect too? We touched on this earlier on. Culturally speaking, are there people who are digging in their heels? Are you starting, on the contrary, to feel that there's a real push in terms of reputation? Xavier LOZAC'H talked about Greta a little while ago. Is the world of shipping beginning to suffer from a less favorable reputation because it is very brown? Who will dare to talk on that point? I think that shipping isn't very well known to the public at large. It's really a matter for specialists and experts. When you put sails on a vessel, that's very visible. And there you begin to get a certain reputation as an industry where things are moving and changing. And you get more support and sympathy when you use wind energy on a ship. So the public at large is ready. Is industry? Well, industry will get there bit by bit. But here again, we have to change the culture that prevails. When you talk about shipping using sails, people think, oh, you're going backwards. People are afraid that things will break. with offshore sailing races, sometimes a mast breaks. But we're talking about the merchant marine and industrial products and very sophisticated, rigorous risk analyses. But as I explained earlier on, both professionals and the administration and representatives of elected MPs, we have to work on the communication side so they adopt this new position. You're avoiding my gaze. Culturally speaking, how do you see things in your entity and beyond? In VINCI Énergies, employees expect us to change culture. They expect changes in the way we provide solutions. We know that in the future, if we want our employees to remain faithful, loyal, and remain interested in what they're doing, and serve our customers well, we'll have to be really good when it comes to all these issues. Culturally speaking, yes, indeed. Like everybody here, we are evolving. There are several shocks, the climate shock. People talk about this every day. So we're taking this very seriously. We have a lot of know-how, and we want to ensure that the whole shipping industry can make the most of it. Xavier LOZAC'H, you talked about the fact some insurers were a bit afraid. I'd like to return to that point. How can insurance play a part in these changes once people have overcome their fear? You are spokespeople for over half the room here. How do you view the medium-term trends? Well, insurers have always adapted to the environment. And we have this growth in awareness that we've been talking about. We talked about climate change. Look at the last fortnight in France in terms of weather. When it comes to shipping more specifically, one senses today that shipping used to be out of sight. You get merchandise or goods, but you're not that interested in how they reached you. But that's changing. We're talking about a company's social responsibility, environmental issues, and we're going to have to adapt. And as insurers, we'll have to reinvent ourselves. We'll have to invent new solutions, talk with our customers to see how we can go about things. Will we still talk about conventional insurance, or will it be something different, something new? I don't have the answer today. We have to reinvent ourselves. That's absolutely necessary, clearly. Our companies, our parent companies wouldn't understand if we didn't become more concerned with the environment. There's a lot of communication about the environment. 2030, 2050, we're at a crossroads. We've seen this in the figures that we saw earlier on. If we continue as we are with the current model, it will become very complicated, both for insurers and insured parties, because there'll be more and more disasters, not necessarily in shipping, but bit by bit will be increasingly affected. So we'll have to participate. It's up to us to imagine the future together with our customers and partners. You were saying that there was some reluctance about carbon in the various structures. Are things moving? In the airline companies produce quite a lot of CO2 too. Let's start with shipping. Oh, you're looking increasingly at these carbon structures? Yes. Allianz has special policies in certain sectors. The most polluting sectors in particular, there we focus on coal a lot. No, I wasn't clear. Vessel structures need to evolve. The actual construction of the hull, for example, reference was made to different materials, materials that may break more easily. Yeah, we were talking about it when preparing the round table, this vision of racing boats. You remember the Route du Rhum in 2004 or 2005? A lot of the boats capsized, so that's not very good publicity for all these new materials, high-tech materials. However, we'll have to adapt. That's definite. How? Well, that remains to be seen. Yes, maybe we'll adapt our terms and conditions. When it comes to carbon, this is quite an old matter in navigation. In the Boeing 747, there were carbon structures introduced many, many years ago. Now the main structure of a plane is over 50% carbon. In aviation, each little piece that you put in an aircraft has to comply with the very complex rules and regulations. Everything has to be certified and proven in all ways. For example, carbon. If you want to build an airframe out of carbon, it's possible, but it has to resist lightning. Every 1,000 hours, there's lightning that hits an airplane. So building something out of carbon, an airframe out of carbon, that's not really worthwhile. It's better to have part in metal and part in carbon. Because if you have to add a whole lot of copper as a lightning rod, then you've lost the benefit. There are lots of things like that, but carbon is widely used in the aeronautical industry and has been for about 50 years. It's in common use. New developments aren't based on carbon. With the new developments today, I don't know whether this can concern shipping, but you have, how do you call this? It's 3D printing, additive manufacturing. With 3D printing, you can gain mass in a considerable manner, but that's another business. That's the future. It has to be certified and comply with regulations, and of course then it can be insured. We have a little bit of time for one or two questions on these rather technical matters. I don't know whether you want any further details. I can't see you very well in the room, but if you wave madly at me, I could take one or two questions from the room. There's a point I wanted to go back to. Earlier on in your presentation, Olivier, on the far right, there was a drop in growth. Over and above shipping, you have this issue of reducing growth. According to some people, that would be the only solution, the only really effective solution. Is that a taboo in your industry? Do people talk about it? We didn't talk about a reduction in growth. We talked about sobriety. It's not quite the same thing. Well, why did I simplify things in this manner then? How can sobriety help? Lowering growth, reducing growth is something that's very negative. It means going down. Sobriety means that you better manage needs and balance things out better in light of the availability of the resources available. We don't consume things in light of the available resources, at least not yet. We haven't reached the limits of oil, but it will soon happen. And this sobriety is more complex because it's not just, as Olivier said, it's not just a question of technology, it's a question of behavior as well. And that's everyone's private life that will be affected and the overall functioning of society as well. I was talking about wind energy. With wind energy, if you want to optimize wind energy, using it as the main propellant, these sizes of vessels will be moderate. You'll have to put into ports where you can load and unload and where you have the right amount of wind. So that'll have an impact on the whole logistics chain. We're not talking just about shipping. Sobriety means you're going to have to organize or reorganize the whole of the supply chain as well. Shipping represents just a few percentages of fuel or the product or merchandise itself. It's not just a question of transport, in fact. Olivier, do you want to add anything? It's not a taboo question, sobriety. These are even things which are broached. We're just at the very beginning, but we're beginning to work on reuse systems, for example. How can one reuse systems, give them a second lease on life, use them differently? We do talk a lot about sobriety when we talk about prolonging the life of a given equipment, giving it a second lease on life. We're looking into the matters. You can see this in some industrial sectors quite clearly. I believe that in the future this will also be true of the maritime sector. We talk about low-tech as well. I come from Concarneau. Some people there are testing a certain number of technologies. Roland Jourdain went off to sea on a linseed boat, a linseed fiber boat. So nothing is taboo. Roland Jourdain, had he launched the idea 10 years ago, he would have been told he was completely crazy. Now he's viewed as a little bit mad, but people are keen to see on what he's able to do. He's being observed to see whether some lessons can be drawn. So I don't think there are any taboo subjects any longer. I've said this since the beginning of the round table, in fact. I don't think there would be one solution. There'll be several. And sobriety will also give us some levers. What is your message for the insurers who are listening to us? Do you have a message? Officially, I would like to give you the microphone to do some lobbying. Do you have a message to convey in terms of decarbonization? There are insurers in the room. You can say everything you have on your mind. No, more seriously speaking, it's teamwork which will enable us to really move forward. If we progress together, or if we don't progress together, we may branch out on contradictory paths. We won't be synchronized. So we need to work together. As an engineer, my door is open to insurers. I can explain to them what we're doing, and perhaps we can adapt solutions in view of what they have to say. They no doubt have something to contribute to future changes. I say I open my door, but I'm sure there are other places also, like the maritime cluster. That's a wonderful place where people can discuss and talk together. Xavier LOZAC'H, what's your message? My message is that we're at the beginning of a new era, and it's up to us to invent everything, to reinvent ourselves for the years to come. It's going to be extremely important to be capable of following our customers with these innovations, find the right solutions, and understand each other. That will be the key. We have to talk together, all the stakeholders, insurers, classification companies, ship owners, insurance brokers. Everyone is a stakeholder, and we all need to work together to find the right solutions. In the plural, there may be one solution for a company, one for insurance market. I don't know, but it's up to us to create all this, to show creativity and imagination. Lise? Indeed, I think it's very important to work together. I think I'd say we need to speed up. There are areas where we don't have solutions, but there are some first solutions which are arriving on the table, and we can't afford to waste any more time. We need to allow solutions to prove their worth. They may not all work, but we need to facilitate their testing so they can prove their worth, and that means you have to be proactive. Wind energy, there are no blockage points. We must forge ahead. Time is marching on. And as this is the lobbying 5 minutes, we have written a white paper on ships propelled by wind. It's online, open source, and we're very happy to share this with you. It will provide some more information. Some of the images I think you showed us come from that document. It's very visual. I have another message. And also to react to what Lise had to say. There's an international competition underway. If we don't want to be the last in this race, we have to speed up. People have talked about countries in the north of Europe which are moving apace. Indeed, but we're already lagging behind a little bit in certain areas, not all areas. So that also is one of the challenges. There's a lot of international competition. You've talked about the north of Europe. There's China. There's the US. What stage have they reached? Is less the case? Well, China, they don't seem to be budging much in this area, personally speaking. Maybe I'm mistaken. I think they're strongly interested in all this, and they have some very discrete projects which are rapidly emerging. And then you have big international consortia which are being put together in Northern Europe, in Asia, around Singapore. So there are a lot of projects which are moving forward quite fast. If we want to have a French industry that's in the forefront, if we're not to be the last to decarbonize, then I think we have to really forge ahead. In the next 2 or 3 years, I think there will be a number of breakthroughs. Xavier LOZAC'H, by way of conclusion, what would be your main message? And 2 things. In terms of the question you put to my partners from the insurers' side, when it comes to fuels, kerosene, 50% of the mass, 50% something else, well, these are known things. We need to improve the dosing, for example, but that's not a real business, the kerosene as a fuel. It's fairly neutral. However, if we move on to something really new, like hydrogen and liquid hydrogen in particular, we're in the same position as with kerosene 80 or 100 years ago. It took a long time to reduce the number of accidents. When you compare the past with now, subassembly on a plane shouldn't suffer from a serious event more than every 1 billion hours of flight. That's a lot, 10 to the power of 9. So a big subsystem to supply hydrogen, for example, has to be that reliable, and it has to be proved. You have to conduct all sorts of trials. It's very complicated. So we have a long way to go still. That's one of my messages in passing. Now, to talk about synthetic fuels, which people talk about a lot. That's the tool that will help us to decarbonize, we hope, completely, 100% by 2050. Well, we know how to make these fuels. There are quite a lot of companies that know how to make these fuels. These fuels will be expensive. I won't give a figure today because there are lots of figures you can read about. The fuels will be expensive, but planes will use half as much. Even if it's 3 times more expensive, but you use half as much, that's not too bad. What about global investment to produce these fuels? You need green energy, you need the right plants. Green energy is intermittent. We haven't fully mastered this. People never talk about the intermittence of green energy for the hydrolysis, etc. if energy, there's a seesaw movement in Europe. If we pool green energy around Europe, it doesn't remain smooth. It's a sort of a peak and trough system. How can you run a chemical plant on intermittent energy? It becomes impossible. So all these things are still on the table. So it's not at all easy. The energy we need for our ships and planes, well, we haven't found the right solution yet. Biofuel, well, we're not going to devote more to biofuel than we do currently to heavy fuels. So I think we may be fairly limited. We'll have to invest thousands of billions for things to work. It may work in aircraft, but for it to work in both aircrafts and ships, we'll need global regulations that are very clear. ICAO comes under the UN. It's a global organization. We'll need to have clear global regulations and clear national policies, too, in the long term. And thus, the energy experts will turn their minds to this. If you're an energy expert, you may not be tempted to invest piles of money in an energy that people aren't going to buy right away. That's my message. Thank you very much. Thank you to all 4 participants at this roundtable. You gave very clear statements. I think we have grown aware of the wall of the energy transition. Is going to be extremely costly to switch from one fuel to another. Thank you very much.